Wien's displacement law. It states that the wavelength of maximum intensity of emitted radiation of a black body is inversely proportional to the absolute temperature T of black body. Lambda maximum is directly proportional to 1 by T. Lambda maximum T is equal होगा B constant, where B is called as Wien's displacement constant and has a value 2.898 into 10 raised to power minus 3 mK. In order to represent graphically the Wien's displacement law, we need a heat source to heat a black body. Here, a black and platinum wire is heated with heat source. We observed on that at a particular temperature 900 degrees Celsius, the wire becomes red. It means that the emitted electromagnetic radiations are of red color wavelength. Further, increase of temperature about 1100 degrees Celsius, the color of black body changed from red to orange. Now further increase of temperature about 1250 degrees Celsius, the black body changes color from orange to yellow and finally becomes white at 1600 degrees Celsius. A graph between wavelength and intensity is shown in figure at different temperatures. This graph represents that as the temperature of black body increases, the maximum intensity of emitted radiation shifted towards the shorter wavelength side, right to left side. A graph between wavelength and temperature is shown in figure. From this figure, we conclude that with the increase of temperature, the wavelength is decreasing. Hence, graph shifted from infrared region to visible region when black body is heated up to high temperature. Therefore, this is known as Wien's displacement law. Wien's distribution or Wien's radiation law. The spectrum of the black body radiation was explained by Wien on the basis of classical physics. If E lambda d lambda represent the energy density associated with the spectral region lying in the wavelength range lambda and lambda plus d lambda emitted by a black body at a temperature T, A lambda d lambda is equal होगा A upon lambda raised to power 4 f of lambda t d lambda, where f lambda t is equal होगा e raised to power minus a by m lambda t. A and A are constants, lambda is wavelength, d lambda is change in wavelength. Wien made efforts to compare the graph of black body with Maxwell energy distribution graph. A lambda d lambda is equal होगा A upon lambda raised to power 5 e raised to power minus a by lambda t d lambda. This is known as Wien's radiation law. This formula is always valid for small wavelength, but for high wavelength it does not valid. Hence, the Wien's radiation law was valid for short wavelength or high frequencies. A lambda d lambda is equal होगा A lambda raised to power minus 5 e raised to power minus a by m lambda t d lambda. और डी इज इक्वल होगा ए लैम्डा रेज़ टू पावर माइनस आई ई रेज़ टू पावर माइनस ए बाय में लैम्डा टी डी लैम्डा. This expression is also known as Wien's law of energy distribution. This law does not hold good at longer wavelengths at higher temperatures.